Hello everyone, we are returning with another intriguing subject. Text-to-video tools have been in the spotlight recently with several notable releases. Lumiere premiered on 23 January 2024, followed by Boximator on 13 February 2024, and OpenAI's Sora on 15 February 2024. This was followed by Stable Diffusion 3 and Snap Video on 22 February 2024. These advancements reflect the evolving landscape of text-to-image AI models. These models, stemming from advancements in deep neural networks since the mid-2010s, generate images based on written descriptions. By 2022, models like DALL-E 3, Imagen, Stable Diffusion, and Midjourney had achieved impressive levels of photorealism. They utilize a combination of language models for text-latent representation conversion and generative image models. Typically, successful models are trained on large datasets sourced from the internet. In 1998, Jan Laken, along with Leon Botu, Yoshua Bengio, and Patrick Hafner, introduced Latent 5, a pioneering convolutional neural network, CNN, designed for recognizing handwritten and machine-printed characters. Latent 5 played a crucial role in advancing image recognition by responding to partial regions within its input field, making it effective for large-scale image processing. Its structure comprised layers for pattern identification, including convolutional layers for feature extraction, subsampling layers for data dimensionality reduction, fully connected layers for classification, and an output layer using softmax for predictions. Latent 5 demonstrated neural networks' practicality in tasks like digit recognition, shaping modern CNN architectures, and contributing to the resurgence of neural networks and deep learning. ImageNet is a crucial database for developing object recognition software, containing over 14 million images categorized across 20,000 classes such as balloon or strawberry, and organized hierarchically. Since 2010, ImageNet has hosted the annual ImageNet Large-Scale Visual Recognition Challenge, ILSVRC, driving advancements in computer vision through competitions where algorithms classify and detect objects from a curated list of 1,000 categories. Led by Professor Fei Li, ILSVRC has significantly advanced computer vision and deep learning, notably in 2012 with the breakthrough of AlexNet. This established a standardized benchmark for algorithm performance comparison and transformed how machines understand visual data. In 2012, the ImageNet competition saw a groundbreaking moment in computer vision with AlexNet, a convolutional neural network, CNN, developed by Alex Krzyzewski, Ilya Sutskever, and Jeffrey Hinto. Achieving a top 5 error rate of 15.3%, AlexNet surpassed the runner-up by over 10 percentage points, credited to its deep architecture enabled by GPU training. Featuring 5 convolutional layers followed by 3 fully connected layers and ReLU activation, AlexNet mitigated the vanishing gradient problem and pioneered dropout layers and overlapping pooling for improved feature extraction. Its efficient training on NVIDIA GPUs significantly reduced training times, setting a new standard for computer vision and catalyzing a surge of interest and research in deep learning, influencing subsequent models and AI applications. The Microsoft COCO, Common Objects in Context, dataset, introduced in 2014 and expanded over time, comprises over 328,000 images annotated with rich information on objects, categories, and key points, including a separate test set of 81,000 images added in 2015 for thorough evaluation. Developed by Microsoft Research and partners, COCO is renowned for its high-quality annotations and diverse image content, offering a valuable resource for training and testing computer vision algorithms. With detailed labels for over 1.5 million object instances across 80 categories and human-generated image captions, COCO serves as a benchmark for assessing object detection, segmentation, and natural language generation models, driving advancements in computer vision and visual content interpretation. Generative adversarial networks, GANs, are a leading technique in deep learning for producing lifelike images by pitting two neural networks against each other, the generator and the discriminator. Introduced in 2014 by Ian Goodfellow, GANs utilize convolutional neural networks to generate realistic samples by training the generator to create data that can deceive the discriminator, which learns to distinguish real from fake examples. Despite their effectiveness in generating synthetic data across various domains, GANs face challenges such as mode collapse and training instability. Nevertheless, they remain a cornerstone in generative modeling, driving innovation in artificial intelligence by creating highly realistic synthetic data. Introduced at ILSVRC 14 by Google, GoogleNet aimed to address limitations in previous convolutional neural networks, CNNs, regarding depth and computational efficiency. Led by Christian Szegedy, the GoogleNet team introduced inception modules featuring parallel paths with different filter sizes to capture features at various scales without increasing computational costs. With 22 layers deep, GoogleNet offers pre-trained versions for ImageNet and places 365 datasets, classifying images into various categories. Its efficient use of inception modules enables GoogleNet to learn feature representations across different spatial scales, enhancing image classification capabilities while remaining computationally efficient. Winning the ILSVRC in 2014. GoogleNet's innovative design and competitive performance mark a significant advancement in computer vision, paving the way for further developments in deep learning architectures. Deep Dream, created by Google engineer Alexander Modvintsev, is renowned for its captivating and psychedelic visuals. Using convolutional neural networks, CNNs, Deep Dream identifies and enhances patterns in images to produce dreamlike and surreal visuals, initially developed for the ImageNet Large-Scale Visual Recognition Challenge, ILSVRC, in 2014. By iteratively adjusting images to maximize neuron activation, Deep Dream amplifies features like edges and textures, resulting in intricate and hallucinatory visuals reminiscent of a psychedelic experience. While originating from Google, Deep Dream has garnered global interest from researchers, artists, and enthusiasts, finding applications in art, science, and understanding CNN's visual processing capabilities. AlignedRAW, an extension of the DRAW network, emerges as a pioneering model in text-to-image generation, developed by Ailman Mansimov and trained on the Microsoft COCO dataset. Representing a milestone in human-machine collaboration, AlignedRAW enables image generation from textual descriptions, showcasing AI's potential to comprehend and create visual representations. Pix2Pix is a neural network model that transforms one type of image into another, like maps into satellite images or sketches into realistic pictures, using a conditional generative adversarial network, CGN. This setup involves a generator creating new images and a discriminator checking their authenticity. Both models learn competitively. The generator aims to deceive the discriminator, which learns to distinguish real from fake. Trained to comprehend input-output relationships, Pix2Pix adjusts its generated images based on discriminator feedback, producing convincing outputs closely resembling the desired style or category. From altering scenes to adding color to sketches, Pix2Pix excels in diverse image translation tasks, proving valuable in computer vision and image processing. StackGN is a pioneering model in text-to-image generation, leveraging generative adversarial networks, GNs, to create detailed 256 times 256 images. Splitting the task into two stages, it significantly enhances image quality. Initially, it generates a low-resolution image based on the provided text, focusing on capturing basic shapes and colors. Then, in the second stage, refinement enhances resolution and detail, resulting in high-resolution images closely aligned with the text. This staged approach enables TagGN to produce realistic images with finer details, surpassing earlier models. Its multi-stage design improves learning efficiency by specializing different network parts, extending its applications to content creation, virtual reality, and automated design, inspiring advancements in generative modeling and AI creativity. CycleGN, introduced by Zhu et al. In 2017, is a specialized generative adversarial network, GN, designed to convert images between different domains without requiring paired training data. Unlike previous methods, CycleGN can perform image translation tasks across various categories using unpaired datasets, such as transforming summer landscapes into winter scenes or changing horses into zebras. It employs two GNs, each with a generator and a discriminator, to translate images bidirectionally between two domains while ensuring cycle consistency loss. This loss preserves content during translation, allowing CycleGN to maintain underlying details while altering domain-specific characteristics, making it suitable for diverse applications like style transfer, season transfer, photo enhancement, object transfiguration, and medical image analysis. AttenGN, introduced by Tao Xu et al. In 2018, is a revolutionary deep learning model that excels in generating high-quality images from text descriptions. It enhances traditional generative adversarial networks, GNs, by incorporating an attention mechanism, prioritizing crucial aspects of the text during image synthesis. AttenGN employs a multi-stage architecture to progressively refine generated images based on input text, with its attention mechanism allowing the model to highlight different words at different stages of image creation. This ensures better alignment between text and visual details, resulting in authentic and contextually relevant outputs. With its capacity to produce diverse scenes, objects, and animals from textual prompts, AttenGN proves invaluable for creative tasks like art generation, content creation, and visual storytelling. BigGN, developed by DeepMind, is an advanced generative adversarial network, GN, renowned for its ability to generate high-quality images across diverse categories. Its large-scale architecture captures intricate details, allowing it to produce realistic images with exceptional fidelity. BigGN's hierarchical latent space enables precise control over image generation, facilitating the creation of visually appealing outputs with varying levels of detail. Techniques like spectral normalization and truncated sampling further enhance stability and image quality. Introduced in 2018 by Andrew Brock and team, BigGN has revolutionized generative modeling, driving advancements in image synthesis and inspiring creative applications in art and computer graphics. StyleGN, created by InVideo, is an advanced generative adversarial network, GN, introduced in 2018, revolutionizing generative modeling, particularly in producing realistic images. Notably showcased on the website tispersondosnotexist.com. Now powered by StyleGN2, it gained prominence for its ability to generate convincing faces. StyleGN offers precise control over facial features, hairstyles, and backgrounds, enabling users to customize images extensively. Its unique style mixing feature further enhances personalization by blending styles from multiple reference images, making it a versatile tool for art, character design, and content creation. GAUGN, from NVIDIA, is an advanced tool introduced in 2019, utilizing deep learning to generate realistic landscapes from labeled maps. Named after Paul Gauguin, it simplifies image creation and manipulation by allowing users to sketch outlines or label elements directly on a canvas. Noteworthy for its ability to translate simple labels into detailed images, Gauguin accurately interprets spatial relationships to produce textured and detailed scenes, facilitating rapid visualization in landscape design, urban planning, and entertainment without requiring complex rendering tools or artistic expertise. GN Breeder, an online tool, utilizes generative adversarial networks, GNs, like StyleGN and BigGN to enable image breeding and manipulation. By blending traits from different images, users can create diverse visuals, from realistic portraits to anime faces. With intuitive controls and real-time feedback, GN Breeder offers a playful yet powerful platform for creative exploration, allowing users to experiment with various parameters and styles to generate unique and often surreal images across different categories like animals or landscapes. StyleGN 2, an upgraded version of NVIDIA StyleGN, boasts significant enhancements in image quality and training stability, introduced in 2019 by researchers like Tero Karras, with architectural changes and regularization techniques. StyleGN 2 surpasses its predecessor, generating diverse and realistic visuals across various styles. By incorporating path length regularization and stochastic noise injection during training, StyleGN 2 produces highly detailed and visually appealing images, making it a leading model in generative adversarial networks, GANs. Its versatility has led to widespread use in art generation, content creation, and visual effects, solidifying its position as a powerful tool in computer graphics. DALL-E, developed by OpenAI in 2021, pioneers text-to-image synthesis by generating images from textual descriptions, drawing on principles from generative models like GNs. Named after Salvador Dali and Walt Pointe, DALL-E showcases AI's creative potential by transforming written prompts into visual artworks. It can produce a wide range of images based solely on textual prompts, demonstrating AI's ability to comprehend and translate human-like descriptions into vivid visual representations. While its code remains unreleased, DALL-E has spurred open-source projects aiming to replicate its functionality, advancing research in natural language understanding and image synthesis. CLIP, developed by OpenAI, revolutionized text-to-image models by training a neural network to understand the relationship between images and text without explicit image labels. Using contrastive learning, CLIP teaches the model to associate similar representations for corresponding images and text while distinguishing dissimilar ones. By pre-training on a vast dataset of image-text pairs sourced from the internet, CLIP captures semantic similarities between images and text, enabling it to grasp a wide range of concepts and relationships depicted in both modalities. This capability has broad applications in image understanding, natural language processing, and building multimodal AI systems. Deep Days, developed by Ryan Murdoch, merges CLIP with Silent to create an open-source text-to-image model by Illuder AI. By blending GPT-style autoregressive modeling with diffusion models, Deep Days generates high-quality images from textual inputs. Through diffusion, it iteratively refines generated images, resulting in visually captivating outputs mirroring the input text. This integration allows Deep Days to produce diverse and imaginative visuals, making it a valuable tool for artistic expression and creativity. Big Sleep, a project by Ryan Murdoch, merges OpenAI's CLIP model with BigGN in a collaborative notebook hosted on Google Colab, representing one of the first popular implementations of CLIP for generating images from textual descriptions. Big Sleep enables users to input simple text prompts and generate diverse, high-quality images. By leveraging CLIP's understanding of the relationship between images and text and BigGN's generative capabilities, Big Sleep produces visually captivating images, fostering curiosity and engagement within both the AI and creative communities. Vadim Epstein's Colab notebook integrates OpenAI's CLIP with the Lucent library, facilitating exploration of the image-text relationship. Leveraging CLIP's capabilities, users can analyze and manipulate images based on textual descriptions, fostering creative experimentation and AI research. Aphantasia is a condition characterized by the inability to visualize mental images, affecting memory recall and imaginative thinking. The intensity of aphantasia varies, with some experiencing a complete lack of mental pictures, prompting investigation into the neural mechanisms of mental visualization. On 27 February 2021, Ryan Murdoch created Aleph to Image, a collaborative notebook on Google Colab, merging Clip and DALL-E's decoder to generate images from text prompts. Developed by AI, this project combines GPT architecture with Clip, enabling users to create visually captivating images from simple textual inputs. Aleph to Image leverages the synergy between natural language processing and computer vision, allowing users to input text prompts and receive corresponding images that reflect the description seamlessly. This innovative approach expands creative expression by bridging the gap between language and visual content, offering a smooth interface for artistic exploration. Catherine Crausen's Colab notebook, known as Rivers Have Wings, played a crucial role in popularizing text-to-image models among users. Inspired by projects like Big Sleep, it became an accessible platform for experimenting with AI tools to generate images from text prompts. By combining VQGN and Clip models, users could input text and witness their words transformed into visual representations, sparking widespread interest in AI-generated imagery. VQGN plus Clip merges the capabilities of VQGN, known for high-quality image generation using vector quantized variational autoencoders, and Clip, skilled in understanding image-text relationships. This integration empowers users to create diverse visual content based on textual prompts, facilitating seamless communication between text and images and democratizing access to advanced AI technologies for artistic expression. Cogview, an AI system from OpenAI, generates detailed images from text descriptions, catering specifically to simplified Chinese, akin to DALL-E functionality. It represents a significant stride in text-to-image synthesis, enabling users to input text prompts and receive corresponding visual outputs. By employing state-of-the-art techniques in natural language processing and computer vision, Cogview's deep neural networks comprehend textual descriptions to produce relevant images, showcasing AI's capacity in merging language and visual content creation. It facilitates creative expression, design, and storytelling by providing a smooth platform for generating personalized images from text inputs. Clip-guided diffusion, developed by Catherine Crausen, integrates diffusion models with OpenAI's Clip model for image creation, marking the pioneering application of this fusion. By amalgamating Clip's comprehension of image-text relations with diffusion models' image quality, this method enhances control over image generation via textual prompts. Users input textual cues or descriptions, guiding the model to produce images closely aligned with the text, yielding visually striking and contextually fitting outputs. This integration offers users an interpretable and customizable image generation experience, enabling the crafting of images tailored to envision concepts or ideas. The OpenAI team introduces Lane 400M, an extensive dataset spanning 2014 to 2021, comprising text-image pairs extracted from web pages, filtered using OpenAI's Clip model, ensuring accurate text-image correspondence. Lane 400M offers a rich resource for training and evaluating models understanding this relationship. Developed by AI, Lane 400M, a powerful language model with 400 million parameters, marks a significant milestone in NLP technology. By democratizing access to advanced NLP capabilities through open sourcing, AI enables exploration of applications like chatbots, translation, and content generation. With its capacity for nuanced language comprehension and coherent text generation, Lane 400M catalyzes innovation and creativity in natural language understanding and generation. Disco diffusion, stemming from Crausen's Clip-guided diffusion, stands out as an advanced text-to-image model renowned for its creation of artistic and painterly images. Developed by AI, It merges contrastive learning and diffusion models, drawing from the Disco framework for improved efficiency and performance. This fusion enables Disco diffusion to produce high-quality images from noise signals, distinguishing itself as a potent tool for image generation. Operating iteratively, the model refines noisy input signals through diffusion steps, gradually molding them into realistic images. Through contrastive learning integration, Disco diffusion learns to differentiate between generated and real images, ensuring visually coherent and diverse outputs. This innovative approach not only ensures realistic image generation but also facilitates the production of varied and captivating images from simple noise inputs. JX-guided diffusion, an advanced image generation technique by Reverse Have Wings and J.D. Pressman, refines the guided diffusion method by integrating diffusion models with clip. Leveraging the JX library renowned for high-performance computing, it aims to enhance image generation quality and efficiency. This innovative approach promises swift progress in producing high-quality images, paving the way for applications like creative content generation, artistic synthesis, and image editing. With its capacity to generate detailed and visually appealing images, JX-guided diffusion holds significant promise for advancing visual content creation in various domains. DALL-E, a specialized model by OpenAI, generates images from Russian text prompts using a unique architectural design and training with RuClip. Similar to DALL-E, DALL-E interprets and creates visual content based on Russian text. This advancement enables effortless visualization of ideas in Russian, fostering creativity and expression. By tailoring image generation to Russian language prompts, DALL-E empowers users to explore creative avenues specific to Russian-speaking communities, expanding possibilities for innovation and artistic expression. PE5, an upgraded version of Eleutherai's deep learning model, excels in natural language processing (NLP) tasks. With enhancements in architecture, size, parameters, and training data, PE5 demonstrates improved performance in comprehending and generating human-like text. Its standout feature is the ability to create mesmerizing animations using the VQGN architecture, making it a valuable tool for researchers, developers, and enthusiasts in NLP tasks and applications. GauGN2, now called NVIDIA Canvas, is an AI tool that generates landscapes from detailed label maps and simple text inputs, producing photorealistic images by integrating segmentation mapping, in painting, and message production in one model. Leveraging generative adversarial networks, GANs, it creates realistic artworks from various texts, trained on collections of works by renowned artists for enhanced realism and detail. Nova Infinity, Microsoft's multimodal model, revolutionized text-to-image and text-to-video synthesis. It pioneers infinite visual synthesis, generating high-resolution images or long videos of any size. Employing an autoregressive over autoregressive mechanism, it models dependencies between patches globally and within each patch locally. The Nearby Context Pool, NCP, optimizes computation by caching related patches as context, while an Arbitrary Direction Controller, ADC, learns optimal generation orders. Nova Infinity surpasses Nova in resolution and variable size generation, elevating visual synthesis capabilities. Latent diffusion models represent a significant advancement in text-to-image technology. Unlike traditional methods, these models apply a diffusion process to a condensed latent representation of images rather than directly to pixel values. This process involves three main steps. An encoder compresses input images into compact latent representations. Latent diffusion modifies these representations to manipulate images, and a decoder reconstructs high-resolution images from the modified latent code. Operating in this latent space offers several benefits, including faster execution on consumer GPUs, the ability to generate high-resolution images flexibility in conditioning with various inputs, and the preservation of intricate details during image manipulation. OpenAI introduced Glide, guided language-to-image diffusion for generation and editing, in December 2021, positioning it as a foundational element for DALL-E 2's architecture. This diffusion model efficiently generates photorealistic images from natural language prompts, enabling users to iteratively refine and finely control the image creation process. Despite employing only one-third of the parameters compared to DALL-E 3.5 billion versus DALL-E's 12 billion, Glide achieves comparable performance. It excels in converting simple line drawings into lifelike images and offers robust image in painting capabilities, akin to Adobe Photoshop but with simpler usability. Notably, Glide produces modifications that seamlessly blend with the surrounding context, including realistic shadows and reflections. These advancements facilitate rapid and user-friendly image creation while mitigating the proliferation of disinformation and deepfakes. To further support research and mitigate misuse, OpenAI also released a smaller diffusion model and a noise-augmented clip model trained on curated datasets. Midjourney is an open beta text-to-image model available via subscription on their Discord server, gaining traction alongside established counterparts like DALL-E and Stable Diffusion. Notable for its user-friendly Discord interface and accessible setup, Midjourney democratizes AI-driven image generation. Developed independently and self-funded, it produces compelling visuals from simple text prompts, showcasing AI's creative potential. Offering various model versions, including the latest 5.2 version for improved image quality and prompt comprehension. Midjourney caters to diverse artistic needs. Versions like 5.1 prioritize coherency and artifact reduction, while others specialize in photorealism or anime styles, exemplified by the Niji Model 5 collaboration with Spellbrush. DALL-E 2, OpenAI's latest text-to-image model, offers image generation through a paid credit system. It represents a significant advancement over its predecessor, DALL-E, employing deep learning techniques to create highly realistic images from textual descriptions. Operating on an encoder-decoder architecture, DALL-E 2 encodes input text, processes it, and decodes it into visual images. Leveraging technologies like large language models, LLMs, diffusion processing, and natural language processing, it enhances image generation capabilities. Built upon components of the GPT-3 LLM and utilizing a 12 billion parameter algorithm, DALL-E 2 incorporates a transformer neural network to establish connections between ideas. Additionally, it integrates the contrastive language image pre-training (CLIP) model to learn the relationship between textual concepts and visual outputs. Trained on extensive image caption datasets for effective image comprehension. Centipede diffusion combines the strengths of two diffusion models, latent diffusion (LD) and disco diffusion (DD), to generate coherent and artistic images and animations. LD emphasizes overall shape coherence, while DD adds details and artistic touch. Users connect LD output to DD input, controlling generation with prompts. The process requires significant GPU RAM, tested with T4 and P100, and may need a Pro account and additional drive space. Two prompts are used, with the option to pause between LD and DD to filter results. DD image size is a multiple of LDs, and parameters can be adjusted batch-wise. In painting, options allow for complex scenes and style mixing, aiding in partial fixes without restarting. A text-to-image model by Boris Daima that was trying to be an open-source version of DALL-E 2. It gained popularity outside of the AI community through memes. After the attention, it had to change name to Cryo because of legal disputes with OpenAI. The successor of Cogview, this text-to-image model supports both Chinese and English language. Cogview to hierarchical text-to-image system generates images with comparable resolution and quality at speeds up to 10x quicker than Cogview when fine-tuned for fast super resolution. Google's competitor to DALL-E, Imagen is a text-to-image diffusion model acclaimed for its exceptional photorealism and profound language comprehension. Leveraging large transformer language models, Imagen achieves superior text encoding for image synthesis, surpassing image diffusion model scaling in sample fidelity and alignment. Notably, Imagen sets a new FID score record of 7.27 on COCO without direct training, with human raters rating its samples on par with COCO data. Drawbench, a rigorous benchmark, compares Imagen with leading models, with Imagen consistently preferred by human raters for sample quality and image-text alignment. Lane 5B is a vast dataset, much larger than Lane 400M, containing 5.85 billion clip-filtered image-text pairs. It includes 2.3 billion pairs in English and 2.2 billion pairs in over 100 other languages. Additionally, there are 1 billion pairs with texts that cannot be assigned to a specific language. This dataset is designed for research purposes. CogVideo, from the makers of Cogview, is a Chinese text-to-video model capable of creating brief GIFs. It's built on a 9 billion parameter transformer designed for text-to-video tasks. To train CogVideo, we utilized a pre-existing text-to-image model called Cogview 2, which lowered training expenses and addressed issues of limited data and relevance. Additionally, they introduced a multi-frame rate training approach to improve the synchronization between text and video clips. Google introduced Party, its text-to-image model, on 22 June 2022 as a competitor to OpenAI's DALL-E. Party utilizes a method called Pathways autoregressive text-to-image, studying vast datasets of images known as image tokens to generate hyperrealistic images. By analyzing tens of billions of inputs, Party constructs new images, with its realism improving as it reviews more parameters. Unlike Imagen, another text-to-image generator by Google that employs diffusion learning, Party does not obscure images with noise. Instead, it directly decodes the inputs to recreate the original image, evolving from decoding random dots to generating detailed images as it refines its training process. Make a Scene is an AI tool from Meta for generating artwork from sketches and text. Unlike other AI systems, it offers greater creative control by allowing users to specify various elements, forms, and compositions, resulting in more predictable and tailored artwork outcomes. Microsoft's Nova Infinity is a pre-trained autoregressive model for text-to-image and text-to-video synthesis. It excels in infinite visual synthesis, generating high-resolution images or long videos of any size. Using a dual autoregressive generation mechanism, it handles variable size tasks efficiently. A global patch-level model captures interpatch dependencies, while a local token-level model considers dependencies within each patch. It introduces a nearby context pool to cache related patches, saving computation costs without compromising dependency modeling. An arbitrary direction controller determines generation orders and learns positional embeddings. Nova Infinity surpasses Nova in resolution and variable size generation, enhancing visual synthesis capabilities for both images and videos. Stable Diffusion, an open-source text-to-image model by Stability AI and Comvis, generates photorealistic images from text and image inputs. Launched in 2022, it extends to creating videos and animations, leveraging diffusion technology and latent space for efficient processing. With minimal hardware requirements, it runs on desktops or laptops with GPUs, offering customization through transfer learning with just 5 images. This departure from previous cloud-based models like DALL-E and Midjourney enhances accessibility and flexibility for users. Dream Booth, developed by Google and Boston University researchers in 2022, fine-tunes text-to-image models for specific object outputs. Initially based on Google's Imagen model, Dream Booth can be adapted to other models, enhancing their ability to generate personalized outputs after training on 3 to 5 images of a subject. By fine-tuning the unit component of diffusion models with subject-specific images and text prompts, Dream Booth ensures diverse and contextually relevant outputs, maintaining minute details through super-resolution components. Meta's Make a Video is an upgraded version of Gaussian, offering a text-to-image model with label maps. By leveraging recent advancements in text-to-image technology, Make a Video enables text-to-video generation. It learns from images and descriptions to understand visual concepts, and from unlabeled videos to grasp motion patterns. This data enables Make a Video to transform brief text descriptions into unique and imaginative videos, bringing users' ideas to life with minimal input. Fenki is an AI model designed to produce long videos directly from text prompts, potentially spanning multiple minutes. It also allows video generation from a single image paired with a prompt. The model's video encoder-decoder surpasses existing per-frame baselines in both spatial temporal quality and token efficiency. It employs a bidirectional masked transformer conditioned on pre-computed text tokens to generate video tokens from text prompts, which are then detokenized to form the final video output. Google's Imagen Video is a text-to-video model succeeding their Imagen text-to-image (T2I) model. It employs a cascade of video diffusion models for generation. Input text prompts undergo contextual encoding via the T5XXL model to enhance language understanding. The base video model then produces a low-resolution, low-frame rate video structure. This is followed by temporal super-resolution (TSR) and spatial super-resolution (SSR) steps, which increase frame rate and resolution respectively, guided by the input text prompt. Design choices include using fully convolutional models for super-resolution at specific resolutions, and progressive distillation with classifier-free guidance for efficient, high-quality sampling. Baidu's Ernie 6LG 2.0, an upgraded text-to-image model, boasts fewer parameters than DALL-E or stable diffusion but excels in spatial understanding and color matching. Developed by Baidu, this Chinese model incorporates textual and visual knowledge to enhance image quality. Ernie 6LG 2.0 achieves state-of-the-art results on Microsoft Cocoa dataset with a zero-shot FID score of 6.75, surpassing recent models in image fidelity and alignment. Researchers utilize a text parser, an object detector, to extract scene elements, guiding the model's attention during training. By dividing denoising into stages with specialized experts, the model optimizes learning without increasing inference time. Scaling up to 24 billion parameters, Ernie 6LG 2.0 becomes the largest text-to-image model, adept at understanding Chinese prompts, generating anime art, and portraying Chinese culture effectively. Midjourney, a collaborative project between Spellbrush and Midjourney, offers custom anime artworks and illustrations. Currently in beta, accessible via an official Discord server, users input text prompts to generate unique anime images. Join the Discord server to access Midjourney during beta testing. Simply navigate to any Hush image generation channel, type the Imagine command followed by your prompt, and start the image generation process. Use buttons to upscale U1, U4, or create variations V1, V4 of your images. Instruct Pix2Pix is a model trained on data from Stable Diffusion and GPT-3, capable of editing images based on human instructions. It's conditioned on both text prompts and input images. The model follows a diffusion process guided by classifier-free guidance, CFG. Unlike image-to-image models, Instruct Pix2Pix has dual conditioning, text prompts, and input images. As a result, it utilizes two CFG parameters, one for text and the other for images. This dual conditioning is reflected in the automatic 1111 GUI interface. Stable Diffusion 2 is an updated version of Stable Diffusion, now fully open source. It replaces Clip with OpenCLIP, developed by Lane with support from Stability AI. Led by Robin Rombach and Catherine Krausen, this text-to-image latent diffusion model builds upon the original Stable Diffusion framework. Stable Diffusion 2.0 introduces robust text-to-image models trained using the new OpenCLIP text encoder. This enhances image quality compared to previous versions. The models can generate images at default resolutions of 512 by 512 pixels and 768 by 768 pixels. They are trained on a curated subset of the Lane 5B dataset from the DeepFloyd team at Stability AI, with further filtering for adult content using Lane's NSFW filter. Refusion is a text-to-image stable diffusion model fine-tuned to work with spectrogram images, which can be translated into audio files. Developed by Seth Forsgren and Heike Martyros, it generates music from sound images instead of audio directly. By leveraging Stable Diffusion's capabilities, Refusion transforms text prompts into image files, which are then converted into audio using inverse Fourier transform. While the resulting music is brief, the model can interpolate between outputs using latent space. Refusion, released on 15 December 2022, is open source on GitHub and belongs to the text-to-music AI generators category. Alongside similar projects like MuBert and Google's MusicLM. Muse.ai is an AI-driven platform streamlining video analysis and comprehension through machine learning. It extracts insights and metadata from videos, facilitating thorough categorization and contextual understanding. Users benefit from automated transcription, saving time and effort compared to manual methods. Muse.ai enhances video accessibility with a robust search feature indexing metadata like transcriptions and annotations. Additionally, its AI-powered editing tools simplify tasks such as trimming, merging, and enhancing videos, reducing reliance on complex software and technical skills. A video-to-video tool by Runway ML to edit videos with generative visuals through text or image prompt. Its public release was on 27 March 2023. On 20 March they announced Gen 2, a text-to-video tool. A neural network structure to control diffusion models through different techniques. It allows more control over the structure of the image through im-to-im. Different techniques include edge detection, depth maps, segmentation maps, human poses. Model scope text-to-video synthesis, from Alibaba's Chinese Model Assay Service library, is a text-to-video model producing two-second videos via English prompts. Key features include a user-friendly design for effortless video creation, accessibility through the Hugging Face Space platform, and the ability to employ linked models and files for crafting engaging and high-quality videos. Gen 2, a text-to-video tool from Runway ML, follows the same paper as their video-to-video tool, Gen 1, released a month prior. It's a multimodal AI system capable of creating unique videos using text, images, or video clips. Runway Research focuses on developing innovative multimodal AI systems to foster creativity. Firefly, a collection of text-to-image tools developed by Adobe, features a standalone web application accessible at firefly.adobe.com. This advanced AI platform enriches creative processes by introducing innovative approaches to brainstorming, crafting, and sharing ideas. In addition to the web app, Adobe integrates Firefly technology into different creative AI models across its flagship applications and Adobe Stock. As a testament to Adobe's long-standing dedication to user empowerment over 4 decades, Firefly empowers individuals to bring their ideas to life with precision and clarity. NovaExcel, a cutting-edge multimodal text-to-video model, is engineered by Microsoft's research team to produce lengthy videos like feature films or animated cartoons. Unlike traditional methods, Novixel employs a cost-to-find strategy, generating keyframes initially to establish the video structure and then filling in details between keyframes using local diffusion models. This innovative approach enables the efficient creation of coherent long videos with minimal resources and time. Version is a text-to-image model known for its remarkably compressed latent space, offering cost-effective image generation. Unlike conventional methods with 4x 8x compression, Version achieves an unprecedented 42x spatial compression, thanks to its innovative design involving two-stage compression, Stage A, a VQGN, and Stage B, a diffusion autoencoder. Together, they form the decoder, reconstructing compressed images into pixel space. With Stage C, learning in this highly compressed latent space, Version requires minimal compute for training, enabling faster and cheaper inference compared to top-performing models. ZeroScope V2, an open-source text-to-video model by Spencer Sterling, builds upon ModelScope's framework, providing various versions with enhanced size and quality. ZeroScope V2, tuned by @Spins, generates watermark-free 1024x576 videos. The V2 version operates at 576x320 pixels, facilitating rapid content creation, while V2 XL upscales videos to high-definition 1024x576 resolution. With manageable requirements, boosting 1.7 billion parameters and volume demands ranging from 7.9 to 15.3 gigabytes, ZeroScope caters to a broad user base. Its training incorporates offset noise on clips and frames, refining its understanding of data distribution for realistic video generation. Emerging as a strong competitor to commercial models like Runway, ZeroScope bridges text and visual storytelling, enabling users to create professional videos swiftly and effortlessly. Additionally, ZeroScope V3, advancing ModelScope's groundwork, offers higher resolution and a 16:9 aspect ratio, positioning itself as a direct rival to Runway's Gen 2 in the text-to-video AI domain. Latent 1 is an open-source text-to-video model, the first of its kind to generate 1024x576 videos. Developed by Kamenduru and based on ModelScope, it allows users to perform text-to-video conversion on their local computers or on Google Colab. Unlike closed-source alternatives, this project offers flexibility and customization options. Latent 1 is free to use and provides unlimited text-to-high-resolution video capabilities, accessible both on local systems and on Colab. Pika 1.0, announced on 28 November 2023, is a text-to-video model accessible via Discord. Pika Labs AI offers a free platform for generating short videos from text or image prompts, catering to various creative needs such as storytelling or content enhancement. Key features include the ability to input text or images for video creation, resulting in approximately 4-second videos at 24 frames per second. Operating within Discord, Pika provides a familiar interface for users and encourages community collaboration through its Discord server. Users can structure text prompts with specific elements to guide the video generation process. AnimateDiff is a text-to-video model powered by stable diffusion technology, enabling the generation of animated videos from static images or text prompts. It utilizes stable diffusion models alongside motion prediction modules to smoothly transition between frames, automating the animation process without manual frame creation. Users can generate animations from text prompts or uploaded images, benefiting from AnimateDiff's seamless integration with stable diffusion for high-quality image generation. SDXL Turbo, an enhanced stable diffusion text-to-image model by Stability AI, operates on 1024px images instead of 512px. Utilizing adversarial diffusion distillation, it synthesizes high-fidelity image outputs in a single step, enabling real-time text-to-image generation while maintaining quality. Comparative evaluations against various models showed SDXL Turbo outperforming multi-step models like LCMXL and SDXL, achieving superior results with significantly reduced computational demands. The model's distillation technique, combining adversarial training and score distillation, contributes to its exceptional performance. Interested users can access model weights and code on Hugging Face under a non-commercial research license and explore real-time text-to-image generation on Stability AI's ClipDraw platform. DALL-E 3, OpenAI's latest iteration of the text-to-image model, boasts improved text understanding and accuracy thanks to enhanced image captioning in the dataset. It excels in translating detailed prompts into accurate images while maintaining safeguards against generating violent, adult, or hateful content. Additionally, measures are in place to prevent the generation of public figures by name and to mitigate harmful biases. DALL-E 3 will be accessible to ChatGPT Plus and enterprise customers starting in early October, and as with previous versions, creators retain ownership rights over the images generated. A text-to-image model, an alternative to latent diffusion models, capable of generating high-quality images in a few inference steps. Latent consistency models, LCMs, speed up the generative process in stable diffusion models. As demonstrated in LCM Loris, published on 9 November 2023. LCMs, proposed in latent consistency models, synthesizing high-resolution images with few-step inference by Simeon Luo et al. Leverage augmented probability flow odds to predict solutions in latent space, enabling swift inference with minimal steps on pre-trained latent diffusion models, LDMs, like Stable Diffusion. Distill from classifier-free guided diffusion models, a high-quality 768 x 768 to 4-step LCM requires only 30 to 100 GPU hours for training. Additionally, latent consistency fine-tuning, LCF, allows fine-tuning LCMs on customized image datasets. Evaluation on the Lane 5B aesthetics dataset showcases LCM's state-of-the-art text-to-image generation performance with few-step inference. Magic Animate is a groundbreaking open-source project that animates videos using a single image and a motion video. It excels in maintaining temporal consistency, preserving the reference image, and enhancing animation fidelity. It stands out for animating images with motions from diverse sources, including cross-ID animations and unseen domains like all paintings and movie characters. Magic Animate seamlessly integrates with T2I diffusion models like DALL-E 3, bringing text-prompted images to life with dynamic actions. Google's Imagen 2, a text-to-image model, advances on its predecessor and is utilized across various Google generative services such as Gemini. Leveraging cutting-edge diffusion technology, Imagen 2 produces high-quality, photorealistic images aligned with user prompts. It operates without preset styles, leveraging natural data distribution. Imagen 2 powers services like Search Generative Experience and Google Labs Image Effects, offering an intuitive platform for creative exploration. Additionally, Google Arts and Culture employs Imagen 2 in their Cultural Icons experiment for cultural learning. Developers and cloud users can access Imagen 2 through the Imagen API in Google Cloud Vertex AI. Lumiere, Google's video generative diffusion model, pioneers text-to-video synthesis with unprecedented realism. Utilizing a novel technique, it creates lifelike videos from concise text inputs, showcasing realistic motion and integrating images and videos for enhanced results. Unlike existing models, Lumiere generates the entire temporal duration of the video at once, focusing on object movement rather than patching together keyframes. Capable of producing 80-frame videos, Lumiere surpasses competitors like Stability's Stable Video Diffusion, offering smoother motion, Google's tests reveal Lumiere's superiority over rival models from Pika, Meta, and Runway, including zero-shot trials. Boximator, a motion control plugin developed by ByteDance for video diffusion models, offers precise control over object movement in AI-generated videos. By delineating motion paths with bounding boxes, users can intuitively specify object trajectories without verbose text descriptions. This plugin seamlessly integrates with existing video synthesis models, preserving video quality while enhancing motion control capabilities. Utilizing hard and soft boxes. Boximator achieves a balance between precision and natural motion, backed by self-supervised pre-training for improved performance and state-of-the-art video quality. Sora, a state-of-the-art video generative model by OpenAI, achieves unprecedented realism and consistency, outperforming previous models. Currently accessible to a limited audience, Sora generates high-quality, minute-long videos based on user prompts, depicting complex scenes with multiple characters and emotions. OpenAI is rigorously addressing safety concerns before wider deployment, collaborating with experts to test for potential biases and misinformation. Detection tools, including a classifier for Sora-generated videos, are in development to uphold ethical standards and user trust. Stable Diffusion 3, the latest from Stability AI, promises groundbreaking features in image generation, with a waitlist open for early access. Ranging from 800 million to 8 billion parameters, it offers scalability and quality options to users. The model combines diffusion transformer architecture with flow matching, emphasizing accessibility and ethical AI practices. Safety measures are in place to prevent misuse, reflecting Stability AI's commitment to integrity. With applications beyond text-to-image, including 3D image generation and video synthesis, Stable Diffusion 3 aims to democratize generative AI for individuals, developers, and enterprises. Snap Video is Snapchat's debut text-to-video model, designed to address challenges in video generation by efficiently handling spatial and temporal redundancies. Unlike traditional architectures, Snap Video introduces a transformer-based approach tailored for video generation, treating spatial and temporal dimensions jointly to model complex motions while reducing computational demands. This innovative model produces videos of superior quality, temporal consistency, and motion complexity, surpassing existing methods and achieving state-of-the-art performance across benchmarks.